Let's talk about on-site oil analysis for pulp and paper industries. When we talk about the pulp and paper industry, we're talking about not just those specific groups, but also anybody involved with corrugated paper, flake board or particle board pressing, woven or fiber spinning, or general craft paper type of industries. So anything that's on those. And what's unique about these industries is that especially in the larger or medium to large size operations, they really are what we call an integrated complex. We quickly think about the paper end of the system, and we'll spend some time talking about that. But if you actually look at the integrated complex together, there's many different types of equipment that are all candidates for on-site oil analysis, starting with when they get the lumber in, and there's a woodyard or chipper equipment for shredding and chipping the equipment. And then if you're in an integrated complex where you actually have the pulp facility, where you've got things like the black liquor boiler and the associated chemical plant works. And then of course you can also have what we typically assume is once the pulp goes over to the paper machine, you've got a series, maybe one or two of these machines, which are many millions of dollars at any one time, which converts the pulp from one end all the way to the end, to the other end, where you have a series of spreaders and rollers, high-speed applications running around 3,600 or more feet per second. And depending on the finish of the paper that you're looking for, there can be any number of calendar rolls or super calendar rolls on the back end. So there's an enormous process. It runs 24/7. High-speed rotating machinery is a common feature here. Everything has to be running all at one end to be able to get the paper out at the back end. Generally speaking, some of the conditions that are unique to this industry are high temperatures, and that's inside the facility. So you can have very high temperatures because of the lots of high equipment, and you've got heat coming off of the actual process. You also have a lot of dust conditions. The pulp and the fibers that are being produced in the paper makes for a very dusty environment, so a lot of contamination in the air at any one time. And you often have very high humidity, especially at the wet end of the paper mill or on the pulp side, because as you can imagine, you're getting that moisture out before you actually align the pulp. So very high humidity, on the order of maybe above 80% in some sections of the mill. One of the takeaways here is that maintenance managers who take care of these industries have fully embraced predictive maintenance as a critical tool for them to extend the reliability and improve the conditions of the mill and improve their cost savings. In the paper industry and the pulp and paper, there are many fine advisory councils. One of sticks out to mind is TAPI, the Technical Association for the Pulp and Paper Industry, who've been around for almost 100 years and have provided fantastic support for the industry in terms of expanding the technologies. Pulp and paper is industry because of the high speed, a lot of bearing systems. We're one of the first to really embrace the predictive maintenance technologies such as vibration analysis, infrared thermography, motor current evaluation, oil analysis, of course, for many years, traditionally off-site, but more on-site as well. Online sensors have been a big push for the last few years on critical equipment, as well as laser alignment and ultrasonic acoustic emission monitoring. So all of these conditions have been used for many times. So as a result of that, maintenance managers are well versed in the benefits of predictive maintenance technologies. It is no longer a discussion. Everybody is doing it. The question is, why would they embrace on-site oil analysis technology as opposed to what they're already been doing? And some of the things that they tell us in the success stories that we've seen is that, first of all, the 24/7 mindset with the continuous production is very critical. So they need results immediately, particularly if a problem is developing as a result of a water or an aggression leak. They want to have comprehensive data required before they decide to shut down a piece of equipment. Because to shut something down, particularly on a paper machine, means that the entire system has to be brought down if you have to take out a roll or a bearing. So redundancy is not always easy, especially on the large systems. They want to confirm and expand their knowledge. Many mills nowadays have got on-site or online sensors that are on some of their critical reservoirs and on their critical bearing systems. So they're looking at data coming from vibration, but walk around and online sensors. They also many have adopted online sensors such as particle counters and in some situations ferrous devices. However, these systems are what we would call just water diviner or initial triggers. And again, if anything is kicking out an alarm, they want to have additional information from a comprehensive set of tests before they take it offline. They also embrace workflow planning. So you generally have a small set of maintenance team that are highly skilled. You have good, highly skilled pipe fitters, mechanics, millwrights, and journeymen, and you want them to be able to work exactly according to the structure and not to have any unplanned work time, because that can affect major events. Who does this analysis? Well, in any one of these pulp and paper mills, you'll find that there's a very good organization already in place. So starts at the bottom here with the oilers and the lubricators. These are very well-trained technicians and technical resources who draw samples right now. They run the tests with an on-site testing capability. They will confirm the alarms and create additional action items, and they'll complete the work orders as assigned. Who's planning and who's watching over them are the reliability engineering group, the PDM managers. They're responsible for task planning. They also do more problem root cause avoidance and analysis. They also do overall site management to make sure that the site's working well. And then above that, most organizations in this industry segment have some sort of a corporate reliability at their headquarters. This group are very highly trained team who overview all asset health throughout the entire organization. They set guidelines and standards for the mills to follow so everybody's on the same page. And they also provide emergency support when a mill needs help on a specific problem or if they need additional resources to be able to figure out what's going on in the industry. So some other concerns when it comes to on-site oil analysis for pulp and paper industries is to consider the lubrication, which tends to be, again, unique for the industry. A particular class of product that is designed for paper machines particularly is something known as PMOs, or paper machine oils. They're supplied by most of the major oil suppliers. And what's unique about those is that they are trying to satisfy two ends of a very large paper machine. One is the wet end and the other is the dry end. And again, these are a whole series of bearings and rollers at different ends. The wet end, from a lubrication perspective, the oil needs to have good filterability characteristics, very strong water separation removal because you have a lot of wet pulp in there. You have to have good anti-wear, corrosion inhibition, and good process chemical compatibility. So you don't want any of the process chemicals getting in and actually causing an unplanned reaction. On the dry end, it's a slightly different. You're more concerned about oxidation stability, foam control, thermal stability because it's on the hot section, deposit control in case there's any deposits or wear or debris, and of course water separation as well. So as a result of that, oils that are developed are designed for both meeting the wet and the dry end. So it's really a combination of what you'd see, the best of a hydraulic oil with the best of some of the gear oil with some of these additional strengths in there, especially for the conditions such as wet environments, as well as considering the long life expectancy for some of these products. So most mills select oils that will meet all these criteria because they want to have one oil throughout the machine. So as a result of that, there's other oils that are in different applications and different components. But let's look at the typical type of components that you might see. So in machines, of course, as you can imagine, the main machine is the system with all the rollers, the motors and drives. So paper machine bowsers, bearing systems, hydraulics, motor bearings, they generally run very clean. You want to worry about water ingression is critical. Viscosity, of course, for film strength. You want to worry about oxidation and acidity because that'll affect the potential for corrosion, as well as, of course, the film strength. Particle count, because you've got tight clearances in several of these valves, filtration systems. Ferrous particle count in case there's any significant wear, especially on geared systems on the back end. Of course, wear metals, additives that are derived from spectrochemical is so important. These need to be constantly monitored. Many mills go on a monthly basis. Why? Ingression is constant. It's a 24/7 operation, so seal integrity is continually changing. You've got large sumps, you've got expensive applications, and then combined with that, some of these mills are in remote areas where you have significant climate change when seasons change. So you can go from very hot summers to extremely cold winters, and you have a dramatic change on the outside, and that will affect the local inside of the mill as well, in addition to how the process is going. Likewise, in the yards and the supporting equipment, gear drives, conveyor belts, stackers, grease bearings, all of these need to be monitored. Some of these are actually exposed to the elements as opposed to inside in the actual housings. Water, ferrous density, viscosity is critical. For grease, you don't need to worry about that, but you do need to consider the identity of the grease. Wear metals, of course, is critical. We want to maintain the existing capability, the environment. Duty cycle changes is much more common out here, whereas up here you've got constant production, constant loads. Here you could have differing loads depending on the environment and depending on the actual equipment that's going in there. So as a result of that, you have a lot more variance. But you have existing predictive maintenance technologies, and you want to augment those by actually confirming or denying that a problem exists. Many mills are in remote locations, so as a result of that, they have to consider their power requirements. And in many cases, even if they're on the grid, their power demand is so enormous, most of them will actually try to produce their own power or have a relationship with a local power company. That said, everybody has to have a backup gensets in case they lose power. If you lose power in a mill by accident, serious damage can occur, and it takes a long time to bring it back up. You have to clean out equipment and everything. So backup generators are routinely monitored because, typically speaking, they are only lightly loaded when they're routinely checked, and so you need to check for base number, viscosity, fuel dilution, oxidation, wear images, soot and glycol on a regular basis for those. For larger environments who have their own powerhouses that have gas turbines or steam turbines already involved, many are steam and they use the steam over on the plant side as well. Water, particle count, viscosity are critical. Acid number, additive elements and varnish are also very much in demand, as well as that some additional ferrous or particle count information is critical. Again, these have large oil reservoirs, they're critical to the plant. In all cases, our recommendation is for you to investigate the Minilab systems. There's different types depending on the mill size, but certainly anywhere from a Minilab 53 to a Minilab 153 is critical for pulp and paper industry. And in addition to that, we recommend the TrueView platform for the asset management because of the amount of assets that are in these systems and how they're controlled.